Okay, so this is 12.2 about matrix multiplication, and we're starting off the assignment by finding each sum of these three matrices on the left and these 1, 2, 3, 4, 5 matrices on the right. So I want you to think about how would you do that and give it your best shot. And we'll come to this in just a minute. So how would you think that we would add these based on yesterday's lesson? Yes. In the first row, first position, we would go 3 plus 3 plus 3. Just keep your corresponding elements together. And your multiplication, or excuse me, your mathematics signs, not multiplication. Today is about multiplication, but right now we're doing addition, right? So then we have our next corresponding element, 5 plus 5 plus 5, and that would go here. And then 2 plus 2 plus 2. And then 8 plus 8 plus 8. Okay, so when we solve this, we're going to have 9, 15, 6, and 24. Does everybody see that? There's another way to write this, and this is called scalar matrix multiplication, scalar multiplication. So how we would do that, and let me erase this. How many times are we multiplying each matrix together on the first, on number 44? We've multiplied it together or added it together 3 times, excuse me. So we can write that as what? It would be like 3 times 3. 3 times 5. 3 times 2, and 3 times 8. And do you agree that's the same thing? All right, there's a way to write this. And to get this 3, we're multiplying everything by 3. So what we do is we move it out here and write it like that. So it becomes this. Okay, and that's how we show scalar multiplication. You know, adding them, that's okay, but this is more efficient and a better way to write what's going on. So you're going to multiply everything inside there by 3.
So scalar multiplication is what you want us to show our work as?
You show it both ways. So we're moving to scalar multiplication. I'm just working into the lesson by showing you the bell work. So you probably wrote it like we did it at first, but we're moving to the scalar multiplication. Well, if we were going to rewrite 45 as scalar multiplication, how would we write that? -4 times 5. Let's put the multiple first. So that would be 5 times -4, and then 5 times 7. And then that's it, right? Because it's just a 2 by 1 array. So it's going to be a -20 and a 35, right? So how can we rewrite that as scalar? Put the 5 outside the matrix. Okay, so this is what you're going to be seeing from here on for scalar multiplication. Are there any questions about how to do this and what it means? You okay? Question? Okay. All right. Let's move forward. All right, so a real number factor such as the 3 that we put outside, that we're going to multiply everything inside the matrix by 3, that's called a scalar. S-C-A-L-A-R, scalar. Multiplication of matrix A by a scalar, C, is called scalar multiplication. So this is the scalar. The whole process is called scalar multiplication. It means multiply everything inside the matrix by the scalar, and that gives you your final matrix. Any questions? Okay. All right, so let's look at our first example. If A is equal to matrix 2, 8, -3, 1, -1, 5, 2, and B is equal to -1, 0, 5, 0, 3, -2, what is 4A plus 3B? Well, if that is B and this is A, then we're going to have 4 times that matrix plus 3 times that matrix. Agree? There it is, shown in the second step. So that means that we have to multiply everything in this first matrix by 4. 4 times 2, 4 times 8, 4 times -3, and so on with the next row. So when we do that, we get 4 times 2 is 8, 4 times 8 is 32, 4 times -3 is -12, 4 times -1 is -4, 4 times 5 is 20, and 4 times 2 is 8. Make sure you stay with your corresponding element locations, okay? And then we do the same thing for the next matrix, except we multiply everything by 3. So -3, 0, 15, and then 0, 9, -6. Any questions so far? All right. So now our next step is to add the two matrices. So when we do that, we're going to go 8 plus -3 is 5. 32 plus 0 is 32. -12 plus 15 is 3. -4 plus 0 is -4. 20 plus 9 is 29. And 8 plus -6 is 2. And that's your answer. So in the end, you can say 4A plus 3B is equal to this last matrix. Any questions over that? All right, on your homework example, look at the first problem. There's a typo, and I've got right here, should be 2. We found that first hour 2. All right, so that number right there should be a 2, not a 9. Okay, so correct that first. Now let's look. They say let A equal this matrix and let B equal this matrix. Find each product and each sum. So the first thing they give us is 2A. So we're going to take 2 times A, matrix A. And here it is, 2 times 2, -7, -5, and 3. So now we're going to multiply everything in that A matrix by 2. So 2 times 2, 2 times -7, 2 times -5, and 2 times 3. And then what is that final answer going to be? So 4, -14, -10, and 6. All right? Easy peasy, right? Now, I want you to work 2, which is 5B, and 3, which is 3A plus 4B. And work those now. I'm going to give you 2 minutes. Okay, so you should be pretty close to finished. If not, make sure you get the correct answers written down. Number 2 for 5B is negative 30 and 20 on the first row, and the second row is 5, negative 55. So that's the answer. Did anybody get anything different? Or any questions? Okay, the next one, you're going to multiply A by 3 and B by 4. And you multiply the scalar multiplication, and then you combine those two using scalar addition. Then you get negative 18, negative 5, negative 11, and negative 35. Right? Any questions? Okay, then let's move on. How easy was that? So the same properties apply with scalar multiplication, just like you would use algebra. So we can use the associative property by switching the order of multiplication, right? We can distribute, and basically that's what we're doing with scalar multiplication. We're distributing, and either way. And then 1 times any matrix is itself, so that's your multiplicative identity property. And any matrix times 0 is that 0 matrix. Remember, we show it with the slanted capital O, the 0 matrix. So let's look at problem 2, solving a matrix equation with scalars. What is the solution of 2x plus 3 times the matrix 2, negative 1, 3, 4, equal to the matrix 8 and 5, 11 and 0. So what is the solution? So again, we're going to have to apply algebra to this. And where's our x that we're trying to solve for? Right there. So everything's got to go on the other side of the equal sign. But it's easier to get these multiplied out first. So this 3, go ahead and distribute that 3 to everything in there first. Right? So that's what we're going to do. So this becomes 6. 3 times negative 1 is negative 3. 3 times 3 is 9. And 3 times 4 is 12. So that's the first step. Now we have 2x plus this matrix equal another matrix. Now we've got to do algebra like we did yesterday. So we've got to get this matrix over here. So we have to subtract it from each side, right? So it ends up right here after you subtract this from each side. So we have 2x equal the 8, 5, 11, 0 matrix minus the 6, negative 3, 9, 12 matrix. Is everybody good there? That's an important step, and I had some people confused on that yesterday. It's just basic algebra, like a 2-step equation, except we're, instead of a variable, we're working with the matrix. All right, now we've got to do the subtraction of these two matrices. So 8 minus 6 is 2. 5 minus negative 3, minus a minus, is 8. 11 minus 9 is 2. And 0 minus 12 is negative 12. So now we've simplified this down to 2x equal a single matrix. Now, all we have to do, how would we get rid of that 2? Divide by 2. So we're going to divide everything by 2. So divide this side by 2 and divide your whole matrix by 2. You could also look at that as multiplying this by a half and a half, right? A half of 2, a half of 8, a half of 2, and a half of negative 12. But I like to just take it the simple way, divide by 2, and divide everything in there by 2. What you do to one side, you must do to everything on the other side. So when we divide by 2, that goes to x, and then divide 2 by 2, 1. 8 by 2 is 4. 2 divided by 2 is 1. And negative 12 divided by 2 is negative 6. And that's simplified all the way down. Our missing matrix is 1 and 4, 1 and negative 6. And if you wanted to check your work, what you would do is plug this matrix back in for x and see if that equals this. And it should. If you got the answer correct, your check will come out. Are there any questions? Still pretty easy. It's going to get a little harder, but not much. All right, so let's look at our next problem over here. And let's work number 4 together. It says solve each matrix equation. To start, use the addition or subtraction property of equality to isolate the variable matrix. So number 4, they give us 2x plus 4, negative 5, 1, negative 12 equal 10, 1, negative 7, negative 2. And my numbers are different because my book was really hosed up last year. So make sure you've got the correct numbers in there because there's lots of typos in this chapter. I don't know why. Maybe they added it quickly at last. But now we're going to do the same thing. So what are we going to do? Subtract this from each side. So you get 2x equals this matrix minus that matrix. There it is right there. So what's our next step? To subtract the two matrices. So do that now. So you should get 6, 6, negative 8, and 10. All right, now what's our next step? Multiply each side by a half or divide each side by 2. So we're going to get the x is equal to 3, 3, negative 4, and 5. And that's your answer. Are there any questions on how to do this? Okay, let me give you 3 minutes to work as far as you can. So on 5, 6, and 7, work as far as you can in 3 minutes. Starting now. And I'll give you the answers at the end. So if you don't get it right, you can go home and work it to the correct answer. Okay, so that's our 3 minutes, and hopefully we'll have a little bit of time left at the end of class and you can come back and finish if you weren't finished. But number 5 was a little bit different, as there's a couple more steps in there. And when you work it, the first thing you want to do is clear the 4 and then subtract that result from each side. So you end up with negative 1/2 x equals, this is what you get right there. So this matrix. So now we have to clear the negative 1/2 off the x. So how do we do that? Multiply by negative 2, because negative 1/2 times negative 2 equals a positive 2 over 2, which is just 1, which is what we want. Is that the door? Thank you. Thank you. All right, so multiply each side by negative 2, and then when you do, you end up with x equals negative 22, 14, 28, and negative 20. And that's your answer. Okay, let me pause the video. All right, so are there any questions on this problem? All right. So now let's get the answers for the next two and make sure that our students who stepped out get that as well when they come back. So if you're an aisle buddy, make sure they get this. The answer to number 6, I'm not going to work the whole thing, but your answer becomes x equals, and it's 3, -1, -4, and 1. And then for 7, you're going to have x equals 20, 24, -12, and 36. Okay, so those are your answers. So now you have all the answers. Make sure that you can work these to the answer. If you can't, that's what you need to bring back tomorrow, and let's start the class off with those. If you can't get the answer, we'll work through them. But I think you guys will do fine. All right, ready to move on? All right, so now we're going to get into something a little more tricky. This is about multiplying matrices. When you multiply two matrices, we have to find them a little differently. You don't just multiply the corresponding elements. It doesn't work that way. What you do is you multiply this one times this one plus this one times that one, and that becomes your first element in your answer. And then to get the next one, again, you're going to take this times, this one plus this one times that one, and that becomes this answer. Then for the second row, you're just going to repeat the process, but on the second row. So it's going to be this position times that position plus this position times that position. And then the last position is this times this plus this times that. And that's how you do scalar multiplication. Now, that was just some little dots and you might have lost track. So let me show you a more formal writing here. So you might want to shoot a picture of this with your phone. But this, like I said yesterday, that's not A11, A12. I will say A11, A12, but it's a row 1, column 1, a row 1, column 2. So they stand for row and column. But when I speak of them, I talk about 1, and 2. I'm sorry, 11 and 12. So here it is formally written out how to work them. All right, now let's work one. Is everybody good? All right, and it'll be on the video. I hate that they're missing this because this is where it gets tricky. So if you take a matrix and you multiply it by another matrix, these are just 2 by 2s. Oh, yay, you're back. Okay, we're doing matrix multiplication now, and it's a little tricky, so I'm going to wait for you guys to get seated here. I let everybody take a picture of this, so if you want to shoot a picture of this on your phone real quick, this is the recipe for doing matrix multiplication. It's a little different. Okay. All right. So, oh, sorry. Back up. There you go. I hope you guys don't get me in the picture. Photobomb. All right. Are we good? All right. I'd be so embarrassed. All right. So we have multiplying matrices. Now, here's how it goes. And they do this step by step. And the more you do it, you know, the first couple times you do it, it's like, oh my gosh, I'm never going to get this straight. Third time, you usually have it down. And from there on, you're good. You've just got to work a few of them and get the rhythm of how each space goes. So let's start. And I'll use the shade here. Working today, yay. So here's our two matrices. We're doing A times B. So this matrix times that matrix right there. So our first step is to multiply the first row of A by the first column of B. So we're going to go 2 times negative 1, which is negative 2. Now, we're going to multiply the elements in the first row of A by the elements in the second column of B. I'm sorry, hold on. I missed the second part. I'm thinking about, are you guys that just stepped out of the room really going to get this, or do I need to back up? And then I messed up. Okay, so let's do this again. So you're going to take the first elements, the first row elements times the first column elements. Okay, so it's going to be 2 times negative 1 plus 1 times 0. All right, and that becomes your first position. So 2 times negative 1 is negative 2, and of course 1 times 0 is 0. So when you add those together, you get a negative 2, and that goes in that first position. All right, now let's move to the next element. So again, it's going to be the first row times the second column. So let me scoot that up. So we're going to go 2 times 3 plus 1 times 4. 2 times 3 is 6, 1 times 4 is 4, 6 plus 4 is 10. And that's what goes there. Next, we're going to move to the second row and repeat the process. And that's how you do these. So now we're on second row, so it's going to be negative 3. Here, let me scoot this up. Oh, it won't let me. There we go. Sorry. All right, so now it is negative 3 times negative 1 plus 0 times 0, which is a positive 3 plus 0, which is just 3. And that goes in that space. And then lastly, to get the last one, we're going to repeat the process, but with the second column. So negative 3 times 3 plus 0 times 4. That goes to 0. Negative 3 times 3 is negative 9. 9 plus 0 is negative 9. And that goes in your last element. Okay, and that's how you do matrix multiplication. And as you can see, the bigger the matrix, the bigger the matrices you're multiplying, you can lose track. So when you do these, don't interrupt yourself or pick up the phone or any of that. Just get on there and do them uninterrupted, and that's my best advice. Because if you get interrupted or like me thinking about something else, you're going to mess up. All right, let's look at our homework. Number 9 and 10, this is on the back of the page. 9, 10, 11, 12 goes with this. Yeah, we're making good time. So let's do number 9 together. And it says, find each product. To start, find the element in the first row in the first column of the product matrix. So here we go. There's your first row, first column. So we're going to go 4 times 3 plus negative 2 times 1. So that's going to be a 12 plus negative 2, which is a 10. And that goes in that first element. So they're giving you the recipe here for the rest of these. So even if you didn't have your notes, look, for the test, you've got it right there. So just understand what they're doing. The next step, we're going to go to the next column. So 4 times 6 plus negative 2 times negative 5. So that's going to be a 24 plus 10. That's going to be equal to 34, and that goes in your second element. So you're always putting it in the answer element of where the two columns and rows intersect, right? Because if you were to scoot these on top of each other, they're intersecting at this third row. Whoops, there. Not third row, sorry, second row. All right, so now go to the second row. Now we're going to go repeat the process. Negative 3 times 3 plus 7 times 1. So it's a negative 9 plus 7, which is negative 2. And that goes where they're intersecting. And lastly, they leave the last one for us. But they wrote it for us. So what's it going to be? It's going to be this and this. So it's negative 3 times 6 plus 7 times negative 5. So that's going to be a negative 18 plus negative 35, which is negative 53. So where is that one going to go? Second row, second column, negative 53. So now write the others in, 10, 34, and negative 2. And that's how you do it. That's your answer. Any questions? Okay, I'm going to give you, let's say 3 minutes here to do 10. If you can make it to 11 and 12, go for it. Sure. Yeah, skip 11 and go to 12. Then we'll do 11 together. Thank you. Good idea. And I'm putting your answers out here for those. About 16 seconds. 10. Okay, the answer to number 10 is on the first row, 7, -3, -4, and 6. 7, -3 on the first row. Second row is -4 and 6. So that's the answer. Now let's go to 12. The answer for 12, first row, -10, 24. Second row is -3 and -15. So if you don't get those, you've done something wrong. Work them again. Okay? 2 times -1 plus 5 times 4. That's your first element. And then your next element, I'm just going to get rid of this thing right now, is going to be 2 times 3 plus 5 times 7. Okay? So it's going to be -2 plus 20 and 6 plus 35, which is 18 and 41. Okay? And that's your answer. Any questions over that? All right. So let's look at our last thing and then we'll go back to number 10. Okay. All right, so the last thing we're going to look at is how do we work the dimensions and how do we know if multiplication is even possible. And the one that we just did, the 1 by 2, let's do this one. 1 by 2, and we had that times a 2 by 2. I'll just put them in parentheses. How's that? All right, so what we want to look at when we do these is you want to state what your matrix is. That's a 1 by 2. The second one's a 2 by 2. Look at the two middle numbers. Do they match? Yes, they do. Then multiplication is possible. If they don't match, it's not possible. That's all this rule's saying. So let's look at some of these examples. So they're showing us here's A, matrix A, and matrix B. So what is matrix A? It's a 3-row, 2-column, so it's a 3 by 2. And matrix B is a 2 by 1, 2, 3, 4. So they want to know, does the product of A times B or B times A exist? So it's a two-part answer. Does A times B exist? Well, we're going to have to go 3 times 2 and 2 times 4. Oh, I hate this. Let's do this side. There we go. All right, so we've got a 3 times 2 times a 2 times 4 matrix. Look at your two middle numbers. They are the same. So the product A times B does exist. Now let's look at B times A. You've got to reverse the order. So it's going to be a 2 by 4 times 3 times 2. Right there. B times A, so B is first now. 2 times 4 times 3 times 2. So look at your two middle numbers. They are not equal. I've got a 4 and a 3. Not equal, so there is no product. It's not possible. Okay? Any questions over that? Let's look at your homework again. And the last ones you're going to work are 13, 14, 15, and 16. So my best advice is to go above these and write what they are. This is a 2 by 2. This is a 2 by 1. This is a 2 by 2, and this is a 1 by 2. So now, is A times C, do we have a product here? Does it exist? So you're going to go a 2 times 2, and times C, and C is a 2 times 2. Do those two middle numbers match? Yes. So yes, this one exists. How about B? A B times A. We've got a 2 times 1, and A is a 2 times 2. Do these two middle numbers match? So then there is no product that exists. Do not do 17. So how about D times C?
Yes.
Let's see.
1 times
D is 1 times 2, and C is a 2 times 2. Do they match? Then yes. And then the last one, B times D, 2 times 1, and 1 times 2? Yes. All right? So you've just got those last few to do and bring back tomorrow. Matrix multiplication is tedious, easy but tedious. So do a good job, and I'll see you tomorrow. Thank you. This concludes our lesson.